Okay, now we're talking about hashes. I mentioned it a few times so far, and I think you have an idea of kind of what it is, but just to make sure that we're all clear, a hash can be an MD5, SHA-1, SHA-256, or SHA-512. Okay, it just depends on who you're talking to. Everybody pronounces it differently. It's a mathematical algorithm that's applied to a file, a folder, or an entire disk that verifies the integrity of the evidence. All right, so and I'll demonstrate a hashing algorithm in just a moment. But a hash is taken prior to imaging. All right, so if we arrive on scene and we now take possession of a suspect computer, as I mentioned, we have a device we can either connect externally or we boot up using some type of write blocking software. All right, we're going to connect to that target PC locally or remotely. We will then run a hash against that target hard disk. Typically, it's going to be the entire hard disk. We'll run a hash against it. It will come back when it's finished and spit out a number, a long string of characters and numbers telling us this is a unique fingerprint for that specific drive. When we're done, we'll then take an image of that hard disk and we'll run that same hashing algorithm against the copy. If both of those numbers come back the same, we know beyond a shadow of a doubt that they are absolutely identical. All right, so if one letter, as an example, if we were to hash an entire dictionary or an entire encyclopedia or the entire Library of Congress, I mean, you name it, whatever it is you want to focus on, if you took a hash of that entire body of work, right, let's just say a dictionary here. Well, if we changed one letter in that dictionary from a lowercase to an uppercase, the hash would be completely different. All right, so in other words, if we were to make the analogy to a computer, if we went to a computer and just simply turned it on, accessed some files, logged in, things are going to change. Timestamps, file access, whether we're read, write, modify, so on and so forth. Anything that we do at that point to that computer changes something. And when that happens, it would then change the hash. And if those hashes are different between our target and our copy, well, then it's no longer valid. Right? If, in a court of law, that would be thrown out. All right, so if we take a quick look here, what I can do is bring up a command prompt. And Windows actually doesn't have a hashing algorithm built in, but there's one called the File Integrity Checker that you can download. It's from Microsoft. So what I've done is I've taken, and actually let me just pull out here, I have a file called hashme.txt that I created. Okay, so it basically just has some bogus information in here, testing the hash to see if it works. Okay, so what I'll do is I will run fciv, and if I just hit enter, it'll come back and say the file checksum integrity verifier. All right, so again, it's from Microsoft. What I'll do is put the -add. All right, so fciv -add, and then I'll put hashme underscore dot text. It would help if I can spell properly. There we go. Getting ahead of myself here. Okay, so there we have it. So it gives us a hash. Right? That is the hashing algorithm, or the resultant hash that once we run it against this file, and that is the actual number there. All right, so let's go back and now change one letter. Let's make this an uppercase H. All right, I will save it, and then I simply run that hash again, and you'll notice that the hash is now completely different. All right, you'll see it up top here. It ends just, you can see they're totally different numbers, but the last two, just to real quickly verify, is an A3. On the new resultant hash is E8. Right, so they're completely different. So if I go back and go back to my notepad and I change that back again, just make it a lowercase h, and save it, run that again, you'll see it's the same as it was the initial time. So it will always, based upon if you have the same set of data and you run that hash, it will always give you the same result. If you change anything, then that result is different. All right, so just something to keep in mind. It's extremely difficult for someone to kind of refute that in a court of law. So if you take a hash and you can show on both sides are exactly the same, you know beyond a shadow of a doubt that data is identical.